I'm here to help you out. Okay, inventory planning. So today's session I'm going to cover on the importance of inventory to the supply chain. Brief overview to the economic order quantity model. Now, why I do that, it won't appear in your essays. I have no idea if logistics people do an exam here, but it's fundamentally underpins of what we do in terms of MRP and material requirements planning and manufacturing resource planning a little later on, in terms of how it manages inventory. And though you will never, I don't think so anyway, you will never have to use such things, it's a good idea to have in the back of your mind, that's how it works, that's where it comes from. So you're able to evaluate and see what's going on a little bit more. There's nothing worse than when you're using a major IT system like an ERP system or a manufacturing control process system and you have no clue about how it's actually operating underneath. So you don't need it in terms of any assessment stuff, but I'm just going to cover it very, very briefly how it works. And that part of it, so to avoid people, because they had a bit of a heart attack last time when I started talking about differentiation and the rest of it, what I'll do is I've made a very short cut-out piece on just the economic order quantity on the website. And so you can actually go and have a look at that one. So I'll just skim over that during here so everybody doesn't go completely glazed on me as I go through this story. A little bit on inventory forecasting. I doubt if I'll get to that, but I might do that in a seminar instead. And a little bit on stock categorization and classification later on. Now, as we're probably hearing from your other courses, inventory is bad. Is inventory bad? Who thinks inventory is bad? Not good for organizations.
Does it depend what kind of business you're running? Like if it's spare parts and stuff, then obviously you're going to have quite a lot of inventory because that's what you do.
Yeah, indeed, and that's partially it, because we often talk pejoratively about inventory as if it's completely all bad. And for sure, as I mentioned before, we have to control it. Because, as you'll see a little in a while, if you don't control it, it can get out of hand, and it costs you a lot of money to manage that and to store it in big buildings, IT systems, people to run it, and all the rest of it. So you do want to try and keep it under control. But often we run away with the idea that you must get rid of all inventory and all this sort of stuff all over the place. But as we saw from the first two lectures, it provides some utility. Obviously, in terms of decoupling customer demand from supply, from insulating production units from the variability of demand, for example, that stuff we saw earlier on. And if you've looked at the bullwhip effect, which you probably haven't, but I'll look at one other time, you'll see that those sorts of effects of right back through the supply chain can be, to some extent, controlled by a proper inventory management system. So it's not all bad. We do need it. But having said that, we do need to think about how we can keep it under control. So typical inventory, raw materials, obviously, basic raw materials, iron ore and such things. Work in progress, such as assemblies. In the Dell factory, for example, there was inventory all over the place, wasn't there? There was inventory actually on the racks, if you saw behind people when they were picking it off. And there was inventory in the tote boxes, those boxes which were shuffled around the conveyors. Quite under control, and if I got time I'll show you a hospital one later on today, but quite under control, but nevertheless it's inventory, it has to be managed. Components at stations, same thing. Finished goods inventory, as in the case of Dell, if you remember, they had to consolidate orders quite often, so people wanted different PCs and mid-frames, and particularly the corporate customers. So they pushed some of the finished PCs, in their case, to a holding point at the end of the line to wait for other bits to join it to complete the delivery. They do that, obviously, rather than just ship one-on-one, because that's quite expensive. They've made a decision, rather than ship one-on-one, we'll hold some inventory at the end of the production line, and in that case, we'll wait until we can consolidate the complete order. Nevertheless, that's finished goods inventory, and in the TV factories, we had lots of this. We called it commercial stock. So once we pushed it through literally a hole in the wall, then it became stock, and it was waiting to be sold and to be distributed around Europe in that particular case. Obviously, we shouldn't forget replacement parts, tools, jigs, all that means the material which you need to repair the production processes itself. All of that has to be held in stock. What happens if you don't have material to repair the production units? Things stop. So if it breaks down, then your entire production line is on stop, waiting for somebody to. Sometimes it can be a tuppenny halfpenny component which has gone wrong. Sometimes it can be a large piece, of course. So we do need to make sure that we carry all the replacement parts, tools, jigs, sundry supplies, things like paper, pens, all this sort of stuff, all of the toners for printers, all that sort of stuff. Sundry supplies, we need to keep all that. Again, we need to keep it under control, and to manage that, it's no use having several years' worth of toner cartridge, or I wish such could have 1 week, so that would be the start. But it's no use having that lot for a very long period of time because of obsolescence risk and the rest of it. Yeah. Pipeline stock, obviously when you have created a product, then it gets shipped to various distribution warehouses. That's next week. And so it's in trucks, it's in retail warehouses, and it's in cross-docking locations and so forth. And so by the time you look at it all, there's quite a bit of stock floating around the place that we have to get our hands on and rethink how to manage that. Yeah. And MRO, I just put it up there just in case you ever see that term, is maintenance, repair and operating supplies. It's a term, I'll put it up as a card. It comes up a lot in logistics. So I'll mention it for the risk management people, or the innovation people, I should say. Now, inventory is holding material or finished goods to manage demand variability. That's it. If we could, I suppose, really organise things so it could be just in time right throughout the supply chain, and we had unlimited funds perhaps, then we wouldn't need so much or very, very little inventory at all. But that's pretty unlikely. And so we do have the situation where we're dealing with a long chain of fulfillment from the customer order right back through retailers, if it's a retail type product, to the distribution chain, to cross-docking locations where we assemble things, right back to manufacturers, to the component manufacturers of those manufacturers, back to basic raw materials, tier 1, tier 2, tier 3, as we saw before. That can be quite a complex supply chain to try and manage. So smoothing out that demand right throughout all of these things can be quite a challenge. And we have very complex systems to do just that thing for us. It's used to uncouple these stages. An inventory point is placed between, let's say, a manufacturer and retail, as we saw in one of those charts with the little inverted green triangles, if you cast your mind back, in order to provide that buffer zone between the two areas, to decouple their demand from the supply, to smooth things out a bit, to make it manageable, so the production processes can proceed in an orderly way. It is rare for us to be able to manufacture, particularly mass consumer goods, on a lot-for-lot basis, a one-for-one basis. We usually have to batch things up and store them in a practical sense. Manage production stoppages, obviously. The logistics people might go and see a factory like BMW, and where you'll see downtimes are quite common. Yeah, indeed. That small things go wrong in such a complicated production process, then things inevitably go wrong with people, but more importantly with the machines, which are running 24/7, in their case 5 days a week. They go wrong, they break down. You have to be able to manage that. on their main production lines, they do stop the whole thing until they repair it. But in most cases, you will need to have some sort of buffer to manage the situation where there's a stoppage in production, particularly for components. Yeah, where a component machine, in our case in the TV factory, where you insert and place component service-mounted devices on a machine, they're temperamental, let's put it like this. So they're very complicated. You're placing electronic components within the thousandths of an inch, yeah? And so very, very precisely. And so those machines go out of sync, go out slightly out of setting, and it can cause a problem. You have to stop, you have to wait. And so you fix it, you reset it, and all that sort of stuff. And you need inventory just to manage those downtimes, those maintenance downtimes. And avoid stockouts to main service. Yeah, we as consumers, we know this ourselves, that we expect all of our goods to be more or less delivered next day, getting more and more that way, particularly for consumer goods. So somebody is holding stock for that. Do Amazon hold stock? Yes. So they hold stock for that reason, so they can, particularly for prime customers, for those they deliver themselves, then they hold stock to make sure that we can get our goods next day. Some little man runs down the driveway with your package, Christmas again, and to do that they're holding stock for customer goodwill to make sure we're happy. And obviously to buy economic quantities, bulk buying. So we hold stock. It's an interesting balance, actually, to how much you should hold in stock, or how you should take advantage of bulk buying opportunities. What's the problem with bulk buying opportunities? They're buying in bulk sometimes. What do you think? Yeah, come on, Ian. Got to find somewhere to put it is one thing. So you've got to find somewhere to put it. So if you're offered something, let's have 1,000 of this instead of your usual quantity of 100, and I'll give you 10% off. You've got to think, okay, good idea, but where am I going to put this stuff? How am I going to get it in there? Where else can go wrong with bulk buying? Let's assume you've got the money, but there's a discount offered, yeah? So you have to balance that. Okay, if I have all of that stock from you in my warehouses, then I carry all the risk of obsolescence, yeah, unless you make a reasonable deal. So if you buy 1,000 of X and it has a certain shelf life, or perhaps it runs out, your product becomes, over time, your product cycles go their inevitable way, they could become obsolete. You have to carry them. And so it costs you money, as we'll see in a second, costs you a lot of money to hold stock. And if that cost of somewhere to put it, obsolescence, the insurance cost, all of the movement costs, that could very, very easily exceed any sort of discount you will get for holding that stuff. Yeah, very much so. So you've got to be very careful. And sales guys, and they'll probably try, or no, some of you at one time or other, will try to give you a discount so you take a bit more stock, particularly at the end of the month. And last but not least, to hedge against future price rises, if you think that the price of a certain commodity will go up dramatically, or something's gone on, you may want to hedge against it and either buy future or actually buy the materials and stock it. Yeah? People idle. Let's carry on manufacturing. What's the big risk in that? Before we move on, is there such a thing as service inventory? I think it's a pejorative question. The answer is yes. Often we think of in service, I think for the innovation people, would you say that, what's specific about a service product, yeah? And one of the things often said if you look from that perspective, is that in a service there's no inventory, yeah? Consumed and is consumed and created at the same time by the person who takes the service. As you rightly point out, there are things that we have to do, and I put your pre-checks for help. I couldn't think of any terribly good examples, but credit checking, for example, is a case where we do some work beforehand, so we store that up before we really do the service. Pre-health checks and all the rest of it, checking in online, are all examples of how we're building up inventory in services. And it's much the same thing. It allows the buffering of resources and this business of decoupling from the actual demand at the point of use. So I put here some may look at this a little bit later on into precisely identifying in healthcare where these particular service inventories find their location. Yeah? I'm just going to, which you all looked at already, I'm sure, but this time, can you just make some notes as we go through the types of inventory costs that this speaker talks about here, just to make sure I've got them all, and I'll close off that part of the session.
Inventory should I hold? One of the principles of supply of goods to a market is that companies hold enough stock to satisfy customer demand without holding too much. So intuitively, just the right quantities of stock to satisfy demand will minimise cost. However, when dealing with thousands of stock-keeping units, the art of balancing demand with supply is intricate. It becomes even more complex when multiple storage facilities are used, and customer service times are short or vary according to the critical nature of products. The best way to understand how much stock you should have is to determine how much it costs you. As a guide, inventory costs vary from 2.4 to 16% of sales revenue. You might like to check your costs before embarking on a cost reduction exercise. In your endeavour to reduce costs, it's important to understand what are the typical costs involved. Well, here are the areas that you should examine. Facility costs. These are holding costs which include rental, mobile and static equipment, utilities and compliance costs. For example, for dangerous goods or pharmaceutical products. Human capital. This is the cost of labour to manage stock. For example, moving it, handling it and counting it. Finance costs. When capital is invested in inventory, the cost of finance is interest, or the lost opportunity of vesting capital elsewhere. Management costs. These are white-collar personnel and information technology charges. Procurement costs. These relate to the cost of purchasing, including inbound transport. Inventory turnover. As a rule of thumb, the faster the stock turns over, the less it will cost you to hold. However, stock turns in some businesses, such as spare parts, will be very low, say 1 to 3 times per annum, whereas stock turns in a fast-moving consumer goods business can be as high as 20 to 30 times per annum. Regardless, increasing stock turns for any business to an optimal level is beneficial. Stock accuracy. If stock records are wrong, vast amounts of time and expense can be wasted sorting them out. Ideally, stock accuracy should be 98% or better. This means that 98 times out of 100, the stock on system actually matches the stock in the storage bin. Lower percentages are always linked to higher operating costs. Pillage and ullage. Unfortunately, theft occurs, as does unexplained stock losses and damage. The cost of these must be factored into your analysis. Service levels. Too rigid or a single service level approach can cost dearly. Companies that will offer goods supplied anywhere, anytime, in any quantity, at the fastest delivery time possible, will have higher levels of stock than those who offer a service level specifically tailored to customer needs. So, in all of this, what is the solution? Know thy customer service levels well. And note, levels are plural. Smart companies segment their supply to 3 service classes. Critical goods. These are products that are needed quickly, such as for medical or emergency. Non-critical goods. These are products needed within a reasonable time frame, but are not necessarily urgent, such as computers, household white goods, and building materials. Scheduled delivery. These are goods which can be built or customised for particular customers and delivered according to agreed delivery times. This applies to some technology products and also furniture. A further delineation may be made between retail, wholesale or end-user customers. In any case, it pays to start with a good understanding of customer needs before advancing to the next stage. Now that you know the inventory cost drivers, what are some of the strategies that can be used to better manage inventory? Here are just a couple. Firstly, vendor-managed inventory. Some companies involved in manufacturing integration or assembly rely on their vendors to manage their own stock until the goods are actually used on the production line. Under this arrangement, the manufacturer doesn't have to carry any stock and only pays for the stock when used. This strategy can save the manufacturer money, but can consequently load certain costs upon vendors. This apparent misalignment of costs between manufacturer and the supplier is beneficial to end customers, as the total cost to supply in fact becomes lower. Another strategy is postponement logistics. This is common to many international manufacturers and is the process of postponing final assembly of goods until demanded in the offshore market where they will be sold. This enables efficient storage of a smaller range of goods while offering a fast response time to the designated market. It has been used in the fashion industry to good effect, and also in industries such as appliances, computers and gaming. With a large number of companies moving manufacturing offshore to South and Northeast Asia, postponement is becoming more common and feasible for smaller markets such as Australia. So, from what I have covered in this session, you will be aware that inventory management is a challenging and inexact science, which should be approached carefully to ensure full understanding and application of the most appropriate supply chain strategy. I wish you every success as you scrutinise this important aspect of your business.
The three main costs. So I'm just going to cover a little bit on some of the theory side of it in a gentle way. So three main costs come into play in an inventory system. Ordering costs, so the administration, the inspection, the transportation and all the rest of it. So what it costs us in total to order a particular product or service, the whole lot. It's not just the, so that's basically the procurement cost, which Constantine will go through, but in a rather complete way. The holding costs, some of which we just heard about in that short video. Maintenance and handling, taxes, insurance and capital costs, as I mentioned earlier, and obsolescence and damage, rather obviously. So it costs us money to hold this stuff in large locations in a country or in the supply chain. And there are stock out costs. And these are more opportunity costs. If you stock out of a good, a product in a retail outlet, then other things being equal, we tend to renege on that particular purchase and go somewhere else and buy it. So from a company's perspective, you have lost a sale due to that stock out. And that tends to be, we regard that as an opportunity cost. It's a lost sale. And it's something we need to take into account. There's also customer goodwill. This is the way that we appreciate or not when we have a low service level from a supply. And of course it causes back orders. If you have a stock out, then you have to put a back order in. So that is an order against a future production schedule to create that. And it takes manage it, you've got to chase it up, you've got to get it out there, you've got to deliver it. So it just adds overall to the costs. Yeah, Lou. So managing inventory economically involves balancing these costs. The cost of holding it and the cost of getting it. And so fundamentally two issues concern us. How much of a stock item should be ordered at a time? So how much should we get? And when should we do it? So and the main factors we've got to try and balance is how much inventory, how much we should order, the replenishment lead time. If you order a product, it takes time to get there. That's all that means. So you have to take that into account. If you place an order on an organisation, it will take some time to get to you, and you need to take that into account. tackle stockouts, or at least to manage that, so we hopefully can minimise that. I mean, and so we settle, as you see later on a compromise on a certain service level of inventory. We state that other things being equal, let's say it's 95%, but other things being equal, 95% of the time we will provide that item to you within a certain period of time out of stock. And 5%, we're accepting by that at 5% of the time, 1 in 20, then we're going to not be able to do that. And so we have a stock out. So it's a balance, because to try and get that service level up to 99% or whatever really is going to cost a lot of money to do. Where we set the reorder point and what we mean by safety stock is another issue we have to think about. So this shows, this diagram here shows that this is the classic sawtooth thing. It is upside. So inventory up the top here and time across the bottom. Quantity Q here is the amount that we're going to actually calculate in the economic order quantity, is the amount that we are going to order to replenish our stock. And the quantity on hand varies along this area here. So that's what arrow means. It doesn't mean exactly that's point, but the quantity on hand varies from 0 up to Q, the order point. Demand on this chart here is idealized to be uniform over time. And so demand in actual practice is quite variable. And so this will be a sawtooth, but then the derivation will look horrible. At some time, as we go down this curve, demand takes up the stock from starting at point Q and falls steadily, other things being equal, down to 0 if we don't do anything about it. Yeah? So people take the stock out of inventory, and it falls down to 0 along this curve D. At some point along this curve, we say, we've reached a point and we are now going to place an order on our supplier to replenish the stock. And that point is given by the lead time. The way I say that is, if we place that order, we make an order on a supplier, we send a confirmation, all the rest of it, other things being equal, that lead time there can be anything from, a couple of days to many months in actual fact. But that lead time is the time it takes from the supplier knowing that we want a replenishment order to the time that it arrives exactly at our location, ready to be used on the production line. That's what that means. That amount there, from that point down to there, is the amount of stock that we need to hold. So at that point here, when we reach a certain level, say we start off with 1,000, when we fall down to, say, let's say 100, we place an order on our supplier, which we hope, based on our parameters, within 3 weeks, let's say, will arrive at our stock location and replenish the stock back up to Q0 at the top there. That's the basic idea behind the this replenishment model. Yeah? With those parameters to minimize the cost of inventory, the cost of acquisition and the cost of holding. And I'll put that definition up on the site. Now, for the logistics people, will go into this in more detail, but I don't think the innovation people really need to worry, unless you want to. Who wants to worry about? So this shows in a graph those two elements of holding and acquisition costs and where it reaches a minimum. Now, the holding costs are more or less, not more or less, they are linear up here. So the quantity, its purchase price, inventory cost, and that's the average in actual fact, rises linearly over time. So holding costs, other things being equal, will rise over time. There are occasions probably where that's not exactly true, but for this model, let's assume that. Can you think of any examples where that might not be true? So at that point in time, there's a sort of a step, yeah? And so you buy a lot of material, and as it rises up, all of a sudden you cannot fit it in anymore in the stock location. You have to find somewhere else, and that tends to bump up the costs just a little bit. But for now, let's assume it's linear. The ordering costs, buying this stuff, the acquisition, making the purchase order, literally sitting down at the system, keying it in, chasing up the stuff, and all of that work falls in this exponential way here. So as the order quantity increases, relatively speaking, per order quantity, the cost will tend to fall. Now this little red dotted line here shows the sum of these two costs, and the economic order quantity from the last page is that there, and that is the place where the costs are balanced between these two. Never zero, but where it's roughly balanced. Yeah. So it's a very idealized view, but this gives you an idea of what's behind some of these big systems when they're calculating this stuff for you. Yeah. Main assumptions, disadvantages. Demand and ordering costs are constant, or they're known accurately. And do you think that's fair? No, it's not fair in real organizations. A new order is delivered exactly when the inventory is zero, or that's pretty much on the mathematical model side of it. It assumes that the order arrives exactly at the point the last item has been consumed, and that's not often the case. No discount is available for bigger orders. You can make these models extremely complicated. Unlimited stock holding capacity, somebody mentioned there, I think it was Alex, that the costs can be step changed as the orders go up, as the quantities go up, and there's no inflation. Yeah, it's a fairly robust approach. You'd be pleased to know that this type of technique can cope with quite a bit of variability in the lead times and the rest of it, yet nevertheless give us a fairly accurate or a fairly cost-optimized quantity that you have to develop. Now, logistics people want to know more about that in detail, but I think probably for our innovation guys, that's probably enough, yeah? Of course, I can go in lots more detail if you really want to. I just want to cover this point here about inventory systems in practice. So if you want to know more detail, go and have a look at what I've put on these slides and on the website if you really want to know a bit more about that. Yeah? And as I say, logistics people will cover it in more detail. Now, inventory systems in practice, two main areas, two main approaches. Reorder level in a fixed order quantity system is where a fixed order quantity is ordered at irregular intervals. What do I mean by that? The demand falls off at a certain rate, and we always order the same quantity of goods to replenish the stock. Yeah? So a fixed order quantity system is the one broad type of approach. A reorder point is set that represents the time at the demand rate until the stock arrives at our location. Safety stock is there to, I'll put a definition on this, safety stock is there to cover for variability in delivery, and it's sometimes as a two-bin system, and I've forgotten to get where the reorder level is the bin capacity. And there's another type, a cyclical review approach, where we have a look every so often, fixed order cycle system, where a variable quantity is ordered and we check it regularly. We go and check the stock every day and have a look what's there, and if it's necessary, then we place an order. You see the distinction between the two? Fixed order quantity, same quantity, and we order it when we need it, so variable time. The other way of looking at it, we check the stock on a regular basis, every day, every week, every month, and we order an amount which is variable. In a fixed order quantity system, an order is triggered at the reorder point. So that reorder point we considered earlier on. Replenishment is continuously monitored. Replenishment is monitored. The time between order varies, but Q is always fixed, yeah, in this approach. At a minimum cost, the quantity Q is this economic order quantity thing I looked at earlier on, rather obviously. And the manager balances the cost of a stock out to the holding cost. That's the balance we have to make. That we have holding costs and we have stock out costs, and we're trying to balance those off. Fixed order cycle systems. A variable order is triggered at fixed intervals. Buffer stock must account for lead and review time. You also have to probably carry a little bit more stock to account for that. Yeah? Whereas in a fixed order quantity system, basically you're waiting for a trigger. Once it's hit that point, make an order. So fixed order cycle systems tend to require more stock to be held and more clerical effort. Tends to be more labor consuming than a situation where you're waiting for stock on your system to hit a particular level. Solve the problem. This is we must decide when to order and how much to order. That's our conundrum. Now, fixed order quantity systems are an advantage when usage rate is reasonably constant. Variable demand but negligible delivery lead time is another. Yes, indeed, because the order itself is not on a fixed cycle, so it comes in when the stock goes out of the door, it hits the reorder point. You must know that your supplier can deliver more or less within the lead time which is set on the MRP system. And you have a bit of safety stock to allow for obvious things like traffic jams or bad weather or stuff like that. But more or less you must know that your supplier can hit the lead time delivery schedule. And perhaps in retail, even that particular slot that you give them. Whether stock is easily monitored, so we can get at it and is easily controlled and managed. And I say, okay, obviously I got it there. Reliably constant lead time or predictable lead time. So shortish lead time, reliable lead time, then you're really looking at those types of product managed by a fixed order quantity approach. Fixed order cycle systems, relatively high unit value stock. So expensive stuff, expensive kit. If you're out on your loaves of bread, it's not quite so much of a disaster as if it's a very high-end television set or whatever in your store that you need to check. So high value stock, so where you need to check it on a regular basis, anyway, to make sure it's still there perhaps. And that's the corollary of the fixed order quantity. Supplier needs basically a regular or frequent order pattern. Why would a supplier need a regular, frequent order pattern? I mean, they have to make the stuff and make the materials and components for you. And so it helps, within reason, because it's never all black and white with these things, it helps that you can support your supplier with a fairly predictable, for them, demand profile, so they can organize their production processes in an effective way and minimize their stocks. If you don't do that, you will nevertheless have higher costs from that supplier over time. And supplier provides a large number of different variable items as well. Fixed order cycle tends to be favoured, and fixed order quantity, reduced variety of items supplied. There's a graph's not on there, but that sort of idea. So it's a bit of a choice which approach you use. In practice, both are. I'm not sure if I say that. Both of them tend to be mixed. Depends on the product type and the product classification, which one you choose. Even within a retail trade, which is more or less a certain way of looking at the world, there are some variability in the way different products are managed. Differences between them based on the demand variability. Fixed order systems must carry safety stock to carry the lead time plus the next review cycle. Yeah, and so in fixed order cycle systems, tends to be fixed order cycle, has to carry a higher level of safety stock, tends to cost more money as a result. And a lot of where extra demand is received just prior to an order, that can also generate a much larger order compared to a fixed order quantity system. So it's also when the demand, this business about, is it actually very level demand in a fixed order cycle system? If a large order comes in by chance just before you are going to place, you're going to have a look, then you may over-order and may cause problems in the supply chain as a result of that. So a lot of things to think about, yeah? So these are sorts of ideas that you have to think about when you're looking at, okay, safety or buffer stock. Safety or buffer stock is used to account for demand and lead time variability. Demand does vary over time. It is not steady like that curve we saw just now, but it varies over time. And also the lead time. Physical delivery of goods and services by whatever transport system is subject to variability. We cannot exactly predict that every single time that delivery will arrive at the docking location. So we have to allow for that, and we make this balance. Set at 95% of demand during the lead time. So all that means is, and you'll know this stuff more than I do, that here we have a classic bell curve. And what we're saying is here that 95% of all the orders fall in this part of the curve. This is quantities along here. So all of our 95% of the time, all of the orders received will be within here. We set our service level at that point. What that means implicitly is we're accepting that if an order comes in over here, let's say, in the demand period, we've got a stock out. Yeah? So that represents the risk of stock. So 5% of the time, 1 in 20, if we set it at 95%, we're accepting the risk of a stock out. And so the safety stock level is set at that sort of 95% level. If we want to set it at a higher service level, that means we have to pay more money, carry more stock, so that we can cover these orders over here. Yeah? And so it's a balance we have to make. What is the cost to us of a stock out compared to what does it cost to carry the extra quantity of goods in our storerooms? And so we make that balance. You can never make that balance at 100%. Now I put a bit of a caveat because this all looks a very good story, doesn't it? About stock management and the rest of it. But if I just think for a moment about real products and services again. So I put this example up here. So if a single item has a probability, so we set our service level of an item in our portfolio at 95%, meaning that 95% of the time when we go to the stock bin, we find it there, and so we're able to satisfy that demand. What do you think? And so we have a 40-item assembly, so we have 40 items in my portfolio. So we go to all of these stock locations to draw it out to make an assembly. The chance of, is roughly speaking 13%, I put in this example, that we have all of the material that we need there. For example, if you look at an assembly for a television set, some of the key components, you need to make sure that you have those, like the IF chips and the rest of it. Other things, the small surface mount resistors and stuff like that, they're about a penny a thousand or something like that. So in those sorts of cases, you carry a lot of that stock. You overstock on some items and you really tightly control others. But what's behind this one here, if you look at an industry, an airline, I think it was the 747, roughly speaking, 300,000 parts. Do you think you could use this inventory management approach to manage such a product assembly? It just doesn't work anymore. I mean, this is one of the other sort of, let's say, limitations for this type of technique for managing inventory. It may work for a sweet shop or for a relatively bespoke production, like making a specialist motorcycle or whatever it happens to be. That sort of product works perfectly fine, and you may even do this manually. But when you start to get to substantive product assemblies, now, as I mentioned last time, the old sets that we used to make, roughly speaking, 1,000 components. The newer service-mounted ones, many more several thousand components in them. You simply can't manage using this type of technique even for those. And so that's why we're going to come on to next time, start to look at, well, next time is about distribution, but just after that, to start to look at some of the better approaches to handling inventory and handling the production process. Because this type of technique tends to break down when you're talking of real products and real components. Yeah, I've got to call it a day there. Can you just glance through this very simple section on inventory classification, because it really is very, very simple. It's a very old technique and it's still used quite a lot. Yeah, so just glance through it. I cannot remember if I put a video up on it, but I'll do so if needed. So next time we'll talk about distribution. So we leave this behind, but I'll constantly come back to order processes, economic order quantities and the rest of it. So you just need to get this vocabulary under your fingers. And if you really want to have a look at how it works, how to derive it, and how to really set the inventory for Coca-Cola, then go and have a look on the website where I've put the example in quite some detail. So see you tomorrow. Please try and read through the case material for supply chain.